All right, numbers 24 through 26, concept 12, which is solving log equations. Let's look at 24a. We have a log equation with a log on one side of the equation, and there is no log on the second side of the equation. So we can change this to exponential form to get rid of the log by writing it as base of 3 exponent negative 2. So 3 to the negative 2 equals x. By writing it in exponential form without the log, it's very easy now to determine what x is. So simplifying 3 to the negative 2, that's 1 over 3 to the positive 2, which is 1/9. Similarly, 24b, if we write in exponential form, the base is 13, the exponent is x, which is equal to 1. The only value of x that would make this equation true would be if x was equal to 0. All right, on 25, we need to figure out what step of this equation is incorrect and then show what the actual correct solution is. So let's go step by step and see if we can find the mistake. So we have a log equation where the first step is to condense these two logs into one log. So to condense two logs that are being added together, we can use the product property and multiply the x times the x plus 1, which gives us x squared plus 1x. So that's correct. Then going to the second step, we need to change this to exponential form. So changing this to exponential form would give us 2 to the first power equals x squared plus x. So if we look at this, we can see that there's been a mistake made because 2 to the first power should be equal to 2, not equal to 1. So I'm going to circle this to show that that's the incorrect step. So let's show the correct solution. 2 to the first power equals x squared plus x. Solving this quadratic equation, we get a factorization of x plus 2, x minus 1, and set that equal to 0. So either x plus 2 equals 0 or x minus 1 equals 0. So we get a solution of x equals negative 2 or x equals positive 1. Now don't forget to check back in your original equation for extraneous solutions. The negative 2 is an extraneous solution because we don't want a negative argument here. So positive x equals positive 1 is the only solution. Going to number 26, we have a multiple choice question, but let's go ahead and just solve the equation from start to finish to see the process here. We have a power equation. First step is to isolate the power. Be careful not to multiply 2 times 6 as your first step because that wouldn't follow the order of operations because of the exponent that's happening right here. So to isolate this, we need to subtract 5, and we get 2 times 6 to the x equals 32. We also need to divide by 2 to isolate the power. So that gives us 6 to the x equals 16. This equation was taught with log equations because in order to solve this equation, we need to log both sides. Without using logs, we don't know what exponent to use for this equation to be true. 6 to some exponent is equal to 16. So by logging both sides, we can use the power property and bring this x in front as a coefficient. So x times log 6 equals log 16. Then to isolate the x, then I just need to divide by log 6. Log 6 is some number. We don't need to know exactly what it's equal to because we're going to leave our answer in terms of log 16 and log 6. So the answer here, the only answer that's equivalent to this is A.